Hello and welcome to Reasonable Data Science, the channel devoted to teaching a reasonable amount of data science in a reasonable amount of time. This video is part 4 in my series on how to use Jupyter Lite for data science. It will show how to clean data, how to format data types, and how to conduct feature engineering, such as consolidating columns, creating dummy variables, and creating brand new data sets. We will continue to use the same Titanic dataset we imported into our Jupyter environment in the previous videos. The link is in the description below. Before we can begin doing any sort of data science, we first need to import the packages. So in this video, we're going to import the pandas package, the numpy package, and the matplotlib packages. I'm also going to overwrite the default settings in Jupyter. So I want to show 1,000 rows in any table output. And I also want to show all of the columns in any table output. And then lastly, we're going to import the Titanic dataset and set it equal to the df variable here. So the first topic to cover is how to clean missing data in a dataset. But before we can clean missing data, we first need to identify what data is missing. So there are two methods that we could use. The first method is the isNA function. So we're just going to say df.isNA and then .sum. And what this returns is a listing of every column in our data set, and then all of the missing rows within that column. So see here, passenger ID only has one missing value in that column, while the age column has 177 missing rows in it. There's one other function we could use, and that's the isNull function. So we could say df isNull.sum, and make sure to put two L's on the isNull. All right, so this isNull is the same output as the isNA, so both of those will get you to the same spot, whichever one you want to use. Now that we've identified the missing rows for each column, we can look at what is the severity of those missing rows. So one missing row doesn't seem like a lot, but let's check how many rows our data set actually has in it. So when we look, we have 891 rows in our data. So one missing value in passenger ID really isn't a lot. But when we look at the age column here, it has 177 missing values in that column. So if we were to take 177 divided by 891, you can see that almost 20% of the age column's rows are missing, which is quite high. If we wanted to look at, okay, what is the actual data that's missing, we could say df.loc, and then within there we could say df.age. We could say isNA, and close it off, and that will actually return the 177 missing rows of age here, if you wanted to analyze what this is like. And so with any missing values, there's two options really that we have to take. We could either drop all of the missing rows or all the rows that contain a missing value. So basically we would be dropping 177 rows of the age column, which is kind of a lot because we'd be dropping 20% of our data. Or we could try and make an educated guess and replace all of these missing values for the age column. So since age is a numeric value, the easiest first step in replacing data is to take either the average or the median of that column and then replace all the missing values with either the average or the median. Since I like using the median more than the average, I'm going to choose to do the median. So what I like to do first is I like to just set up a median variable. So I'm going to say df of median. I'm going to say equals df of age. And then we're going to say dot median on it. So then if you were to say print df median, that should output a number, which is 28. So the median age of the age column is 28. So to replace all those missing values with the df median variable or the value 28, we can use the fillNA function. So we're going to say df of age set that equal to df of age, do dot fill NA, and then within the dot fill NA, we're going to say df of median. And then let's execute that. And now if we were to run our isNA function again, it should show no missing values in the age column, which it does. There's now 0 missing values in that age column. So we were to successfully replace all of those missing values with the median value of the age column. Again, that's just a very basic way to replace missing data. You most likely want to use a more advanced method by analyzing all the missing data, and maybe you can use the data surrounding it to try and make a better educated guess on how to replace it. But that's a lot more advanced. For now, we're just going to do something simple and replace it with the median value. So replacing a numeric variable is easy. We can replace it with the average, the median, or whatever type of value you want. But how do we replace data that's missing that's non-numerical or categorical? Well, we can use that same fill NA function, and then we're just going to fill it with something that's non-numeric. And so if we look at the embarked column here has 2 missing values in it. And so let's first look at what's the distribution of the embarked column category. So we're going to say df embarked, and then value underscore counts. And I'm going to say normalize equals true. So that way it's a relative frequency. And when we look at the categories within that embarked column, 72% of them are from the S category, while only about 28% are combined between C and Q. And so if you had to make a guess or a bet on what the 2 missing values are, you'd probably say the S value because that has 72% of the records in it. And so we're going to do the same thing. We're just going to take a guess and say, let's replace those 2 missing values with the S value in the embarked column. So if we say df of embarked, we're going to set that equal to df of embarked dot fill NA, and then we're going to fill it with the S value here. If we were to run that, we can then look at df is NA dot sum again. And you now see that the embarked has 0 missing values in it. And so that's a way how to change categorical data, how to fill missing categorical data with the most popular category of the column there. Again, that's a very basic way to do it. You'd most likely want to really analyze the data surrounding the missing data to maybe make an even more educated guess. But for now, using the most popular category seems to work. If we wanted to just take the extreme method of let's just remove some of the missing rows, we can remove the one missing value in the passenger ID column. And so if we first start out and say df.shape, we have 891 rows. So if we were to remove this one row here in passenger ID, we should be left with 890 rows then. So what we can do is we can use the drop NA function. So we're going to say df.drop NA subset equals, and this is where you're going to say passenger ID, and then in place equals true. So we run that, and now if we were to say df is NA, that's sum again, the passenger ID now shows 0 missing values. If we were to look at df.shape again, we now have 890 rows, so perfect. We successfully dropped that one row that contained a missing value here. The second topic I want to cover in this video is how to format data types. So when you import data into Python, Python takes a guess at what are all the data types in the data, and sometimes it guesses them incorrectly, especially when it comes to um, date data that has date formats. It usually brings those in as objects. But let's just look at all the data types based on each column. So how we can do that is we can say df.dtypes, and this just returns a list of our columns and all the data types. And so a float 64 means data has decimals on it. An integer means it has no decimals. And an object means it's text data. So if we were to look at passenger ID, let's just look at the first couple rows of passenger ID here. You'll see that passenger ID has decimals on it. That doesn't really make sense since it's just an ID. So let's replace and change passenger ID from being a float 64 variable, having decimals, to an integer, a variable. So what we're just going to say df of passenger ID, set that equal to itself df of passenger ID, and then we're say dot as type, and then here we're going to say int 64. And we run that here. And if we were to say df.dtypes now, you'll see that passenger ID is now an integer 64 variable. If we wanted to go the opposite way, let's say parchment here, we want to change from integer to float, we could just do the same thing. We'd say df of parch equals df of parch dot as type, and we'd say float 64. And then if we said df.dtypes and run that again, you'll see that parch is now a float 64 variable. As I mentioned before, Python usually incorrectly guesses date formats and usually brings them in as objects. I don't have any dates in this data set, but I wanted to show you the code how to change a date column from an object to a date time format. So if you have a date, let's say we have a column called date in our data set, we just say df of date, and then we'd set that equal to pd, and then we'd say date time index, and make sure you capitalize the D and the I in that datetime index function. And then we just say df of date. And that would then override that date column and change it to a datetime format. All right, so the last item to discuss in this video is what's called feature engineering, which that's really just a fancy term that means to create new variables in the data set based on existing variables. So feature engineering can take on many forms. One form is to consolidate categorical data within an existing variable. So for example, let's say we wanted to change the categories within the embarked column. So if we remember, if we say df.embarked.value underscore counts, you can say normalize equals true. Remember, 72% of our records are in that S category. So basically, our data is embarked S or not S. So we can do some feature engineering and simplify this column down so it only includes 2 categories, not 3. And so how we can do that is we can use a function called np.where, which is basically an if statement. And so if you're an Excel user, it'll be the same thing as doing equals if, or if you're a SQL user, it'll be kind of the same thing as a case statement. But what we're going to do is we're going to override the embarked column. So we're going to say df.embarked, and then we're going to set that equal to np.where. And then the first argument in the np.where function is the statement. So we're going to say df of embarked, and we're going to say whenever it's equal to s, We're going to then give it the S value. Whenever it's not equal to S, we're going to say non-S. So again, we're saying whenever the row or whenever the embarked column equals S, give it the S value. Whenever it does not equal S, give it the non-S value here. And so when we run that, we can then come back up here and copy our value counts. And what we should see are now we have 2 categories instead of the 3. So the S category stayed the same. There's still 72% of the data in S, but now we consolidated the C and the Q categories into a variable called non-S, and it has 27.5% of the data in it. So a very simple way to make this embarked column a bit more simple. Let's say we wanted to create a new column called age groups. And within this column, we're going to use the age variable, which is numeric, and we're going to create within the age groups column categories. And so based on the age, I want to create categories called kid, teen, young adult, adult, and senior, let's say. What we can do is we can use that same np.where function that we used up here, but then just use a multiple of those np.where functions to create basically a nested if statement here in Python. So I'm going to create a new column called df age groups, and then set that equal to np.where. And the first argument I'm going to use is I'm going to say df of age. And if it's less than or equal to 12, then we're going to give it the category called kid. So anytime the age is less than 12, that's going to be called a kid category. I'm just going to take my cursor and bring it down a few rows here, just so it's easier for you to see it. So then we're going to do a comma, and we're going to do np.where, and make sure to do 2 parentheses here. And then we're going to say df of age. Whenever it's greater than 12, close that parenthesis, and parenthesis df of age. Whenever it's less than or equal to 17, close that parenthesis, we're going to give it the category called teen. So if the age is greater than 12 and it's less than or equal to 17, then those records are going to be in the teen category. I'm just going to bring my cursor back here. Then we're going to do another np.where statement. And remember to open parentheses. Whenever the age is greater than 17, let's say, close the parenthesis, and parenthesis df of age, let's say, is less than or equal to 30, close that parenthesis, we're going to give it the category called young adult. So if the age is between 17 and 30, or greater than 17 and 30, we're going to again give those rows and label them as young adult. I'm going to do another np.where statement, and this time say df of age greater than 30, and df of age less than or equal to 50. Then I'm going to say that those are adults in our data. And finally here, I'm going to do np.where, and this time just 1 parenthesis. Say df of age. Whenever it's greater than 50, I'm going to call it a senior. And then if there's data that doesn't meet any of this criteria that we laid out above here, we're just going to call it other for now. And then you're just going to close your parentheses here. So you can see as I close my parentheses, the cursor works its way up the rows here. All right, let's run that. And as you can see, with using this np.where statement or function, you can add as many criteria as you want. So you could just keep building this out and out and out, and just have a ton of different categories if you wanted to. But let's now analyze to make sure our np.where function worked here. So let's just say df of age groups, and we're going to say dot value underscore counts. And within it, I'm going to say normalize equals true. And so it looks like our function worked. So we have all the categories, young adults, adult, kids, senior, and teen that we laid out here. And then all of the percentages of the rows that correspond to that one here. If we were to look at df.head real fast, we would see that we have a brand new column over here called age groups as well. And depending on the age, 38, it falls into the category. So if we were to look, 38 is between 30 and 50, so it should be an adult. Oh, yep, it looks like it's working correctly. Another form of feature engineering is called creating dummy variables. So dummy variables are actually super important to learn because that is how you include categorical data when using a linear or logistic regression algorithms. So what dummy variables do is they take categorical data and make it into numeric data by adding new columns. And so if we wanted to, let's say, change this column here from a categorical to basically a true or false or 1 or 0 column, we could use the function pd.getDummies. And so we're going to say df equals pd.get underscore dummies. And then we're going to say df, so we're going to change the df a data set. So we're bringing in the df into the function. And then the prefix is what we want the new columns to have before including the name here. So we're going to say prefix gender. And then we're going to say columns, and these are the columns that we want to create the dummy variables on. We're going to say this column here. And then drop underscore first equals false. So that way it includes both of those variables. So if we run that function, and now if we were to look at df.head real fast, we should have 2 new columns in the data set here. And so you see that there's 2 new columns, both of the prefix of gender on them, because that's what we specified in our code here, prefix gender. And then it's followed by the unique value that was in that column. So there's a female and a male column. And then it's saying whether it's true or false, basically a 1 or a 0 here. And so using these dummy variables is how we can include categorical data in a linear or logistic regression algorithm. We'll actually learn more about dummy variables in video 5 when we build a linear regression algorithm to predict home prices. So the last topic on feature engineering is, let's say we wanted to create a brand new data set that only included the records of people who are 3rd class and if they died on the Titanic. So we only wanted to analyze 3rd class passengers that died. We can use the same filter function that we learned in a couple videos ago. So we can say filt equals df of p class. We're going to set that equal to 3 and df of survived equals 0. And now what we can do is we can use the loc function that we learned a couple of videos as well, but we're going to set that loc function to equal to a new variable. So we're going to say df of 2 equals df.loc, and then within the loc function we're just going to say filt, and that's going to filter all the rows based on our filter function here, and then it's going to set this new data set equal to df2. So let's execute this here. And now what we can do is we can say df2, look at the shape, And there's only 371 rows in DF2, while the shape in our DF, or our main data set, was 890. And so it's a subset of the 890 that we grabbed. If we were to look at DF2, let's say, of P-class, since we only created the data set where P-class equals to 3, the unique value should only show third class on there. If we were to look at DF2 of the survived column and look at the unique value, it should show 0 because that's what we filtered on in this data set. So it should only show 0 in here, which it does. Shows 0 right there. So that's a very simple way on how to create brand new data sets. If you wanted to take your main data set, filter it down, and then separate it from the main data set, so that way you could analyze that separated or subsetted data. So in this video, we covered how to clean data and replace or remove those missing data, how to change the formats of the data types, how to create and consolidate columns of data using feature engineering, how to create dummy variables, and then how to create new data sets. So thanks for watching this video for my series. If this was helpful, please like and subscribe to keep on getting updated content. And again, search Reasonable Data Science to watch any other videos. There's lots of other videos on the channel, such as how to analyze stock data using Python. In an upcoming video, video 5, we'll look at how to build a linear regression model to predict home prices.